go. Sorry about that. Okay. So let's go over a warm up first, and then we'll go through some other problems. We'll take a break in there somewhere. Looks like it's raining now. I don't know. We'll decide in a few minutes what we're going to do. So I go to a problem. And I say, there's definitely not a common denominator. I can't do anything to the denominators. I can't factor them or anything. So I really just need to make sure I can make a common one where kind of everything's represented. So what I notice first is these both have 4, so I'm going to need a 4. Okay, so that was exciting. I notice that this one has a b squared, so I'm going to have to put a b squared. And I notice this one has an a, so I'm going to have to put an a. I just need to write things alphabetically, so I'm going to write it as ab squared. If you write it as b squared a, it's fine. I like to be proper. Any questions with how we got that common denominator? Okay, so you change your numerator. I have the 4 and I have the b squared, which means I had to multiply this by a to get the common denominator. So I do the same thing to the numerator. 5a squared is what I get. And then over here I have the 4a, so I would need to multiply this by b squared. That will give me 2b squared. And the whole point of doing that is so now we can actually combine these fractions to make one fraction over that common denominator. And all I can really do is write 5a squared plus 2b squared, because none of that can really combine together. Nothing reduces, because they would all, every term would have to have it in common. So that would just be my answer. And I would say that a could not equal 0, because there's an a in the denominator, and b could also not equal 0. Would be my restrictions. So just as a heads up. I'll do that up for a second. I'm not trying to rush it. But as you're trying it on your own, see what you did. Is there any part of that question that people have an issue or would like to clear up before we move on? Isn't that just great, guys? Okay. So that one's not bad, right? There's not a lot of polynomials going on. There's not a lot of different binomials. But just remember the idea. If it's in the denominator, you need to represent it in the common denominator. Anyone still need that? Okay. So let's look at a few other problems, because they're not always going to be like that. Not that much. So let's look at one like this. Okay. So this one now we have some binomials going on. And we say to ourselves, okay, there's not a common denominator. So next step is, can I factor the denominators? And I can. This first denominator, we'll factor 2x plus 2x minus 2. And then over here, I can't really do much. Okay. So I always rewrite it with the denominators factored. And then I make sure I'm going to try to find my common denominator where everything is represented. So I'm going to need an x plus 2. I'm going to need an x minus 2. And here x plus 2 is already represented, so you do not need to write it twice. So we're all set. If it's there, it's kind of represented. If you do need to change the numerator, now is the time to do it. This and this are the same, so the numerator stays the same. This only has the x plus 2, excuse me. So I would need to multiply it by the x minus 2 to get to change the numerator. And that would give me 6x minus 12. Okay, so we're looking a lot better. We have the common denominator. The reason we do that is so we can now write one fraction. We want to combine. So our new fraction, I keep the denominator. So once again, you feel like you're writing this like a million times at some points. But I like to kind of write it rather than do it in my head. Here I can combine my terms. The 1 plus the negative 12 will give me what, negative 11. And then I just have that 6x. So I'll write it as 6x minus 11. There's nothing else I can really do. I can't factor the numerator. There's no common factors or anything like that. So all I'm going to do is write my restrictions. X cannot equal negative 2 or positive 2. And that would be my final answer. Any problems with that? Look at you guys just on a little ski here. Oh, okay, this next one. Actually, I might have you guys try this next one because it's not that bad. Once again, we're not trying to kill you with the actual type of problems. It's really just like basically you know the basics. You understand the concept type deal. So I'm gonna have you guys try this one because the numbers aren't bad. Okay. So we start with a nice little problema. We have some denominators. They are not common. I'm actually more interested in how people do it because there's two ways you can do it. So in your head, if you thought, I need to make them the same, what would you do? And then you just see how far you can follow along. Anything's better than nothing. You're just trying it for now, and then we can kind of clear up if you have any questions in a minute. It's one of those sometimes you just have to try it and see if you're good. Block 6.
Do you always want to like the most simplified form?
So I'm always gonna say factored form. So like, if you can factor it, do it.
Okay.
And then if you can reduce it from there, great. If not, you just kind of leave it. You don't have to go back.
Thank you.
Yep. Another minute. All right, so let's see what you did. Because you can do this kind of two different ways. It's really just preference. One thing you could do is say, oh, there's not a common denominator. You could factor the first numerator and take out the 3. And then kind of see, oh, they have this in common, whatever. Or you could just say, hey, 3m plus 6, if I just multiply the other one times 3, I can make them the same. You can do it either way. So it actually ends up being the same exact thing. Sometimes you recognize something, sometimes you don't. I'm just gonna say, oh, if I just multiply this entire thing by 3, that will make a common denominator. But also if you had just factored that, you would have noticed it was the same binomial, just multiplied by 3. So it's just sometimes how your brain works there. If we do it to the denominator, we do it to the numerator. We keep the denominator. We combine the numerators. I mean, if you left it like that, because you notice right away nothing's gonna cancel, go for it. But most of the time, I say write it in factor form. And then once again, it's a little bit easier to see the restrictions once it's factored, because you would say that m cannot equal -2. That's why I also like to factor it. It just makes that a little bit more. But yeah, nothing reduces, nothing fancy happens. But you just go as far as you can until you can't go no more. So you guys try that one on your own. Do you think you had any questions on those? Oh my gosh, we're just chugging along here. Okay, loving life. So let's look at, I really only have like 2 more and then like one kind of fancy one. There's just a multiple choice on it, but I want to at least, you should be able to do it, but I wanted to show it to you. And then we can maybe go back to your last week's assignments and see if you wanted to go over any of those ones or if you had any other specific ones you wanted to try before we left today. But if you're feeling comfortable with these, you should be good tomorrow. So please, some of you are like, your little balls of anxiety, and you like have a heart attack because we're gonna have an anxiety. So if you can do these, you're fine tomorrow. So just take deep breaths, you're gonna be okay. And we'll go from there. So anytime you start an addition or subtraction problem, you'll look. I need a common denominator, I don't have one. I'm going to factor the denominators. So I have b minus 4 over, what would that be? B plus 4, and that would be b minus 2. And then that's just b plus 2, and then that would be b plus 2, b minus 2. Okay, so I can do that. I feel like we do that every time. Now the most important thing is you find a common denominator. So I'm just gonna go through my denominators and make sure everything is represented. This part's gonna be kind of annoying because it's a lot writing. I need b plus 4. I'm gonna put it in the common denominator. I need b minus 2. Throw it in there. I need b plus 2. I just kind of go in order. Yep.
Wouldn't that be b plus 4 and b minus 4 since it's 16? On the
Oh yeah, where was I getting 2 from? Thank you. I'm sorry, I was just writing so many 2's there, I got a little crazy. So be careful. Don't be like me, oh my god. Okay, it has to, oh no, this is b plus 4, b minus 2. B plus 4, b minus 2. Okay, I'm good. Thank you for telling me because I would have just gone crazy. So now as I'm going, I kind of just go through each denominator individually. So I just kind of work my way through and then I say, oh, b plus 4, already got it. So I'm good. But b minus 4 is not represented anywhere. So I'm going to have to add that to my common denominator. I feel like we didn't see a lot where we maybe had 3 on binomials, but you can have as many as you need to have everything represented. So just keep that in mind. So now I go back and just look, what do I have to do to the numerator? So I think, okay, b plus 4, b minus 2, but that b minus 4 is not represented in this first one, so I'm going to have to multiply that. Remember, this is like a little distributing problem, so you need to put parentheses just to remind yourself. When I distribute that out, I get b squared. That would be minus 4b minus 4b, so that would be minus 8b plus 16. I kind of go back, okay, let's go to that second one. What's represented? I have the b plus 4, I have the b minus 4, but I'd have to multiply it by the b minus 2. Once again, I'm just going to kind of remind myself, this is a good old distributing problem. So that would give me b squared plus 2 minus 2 would cancel, and then minus 4. Okay. Wait, whoa, did I do that right? Yeah, sorry, I just scared myself. I totally did wrong on my paper. I don't know what I was doing. Once again, okay. I don't trust myself. If you see me do something wrong, let me know. All right, so now I try to combine everything together. I need to rewrite that stinking denominator again. I'm getting sick of rewriting it, but if I don't rewrite it, I'll confuse myself. So I'm just kind of trying to combine as much as I can. B squared minus b squared, those are going to cancel, right? Please make sure with a subtraction you do subtract both terms, so be careful. Because it's negative 8. Oh, it's just negative 8b, I'm sorry. Because there's no other b to combine with it. But then it's 16 minus negative 4, which would give me 20. All right, because when you're subtracting negative, you add. I don't know what I did before, but it's also crazy. So what do we got? There is a GCF there of negative 4. I'd be left with 2b plus 5. That doesn't really help me because I can't really do much more, but I always check. And I do my restrictions. B cannot equal negative 4, positive 2, or positive 4. I don't know what that is. saying the square root of 16 is 2. Whew. Okay. Let's do one more, then we'll take our little break. Any questions with that one? Yes.
Shouldn't it be 2b minus 5?
Oh my.
It's positive 20 equal to negative, so it's minus 5.
Yes. Yep, just tell me what I'm doing today. Thank you. Anything else? Anything else I could run? But that's, the main thing is if you can find that common denominator and deal with those numerators, you should be in good shape. Don't make silly mistakes like I make. My brain is not working lately. Okay, so one more, we'll take our little break. So we've talked about this, how the situation just always ends up popping up. Guarantee you can see it tomorrow. You kind of look at the denominators, you're like, oh, those look similar, but not exactly the same. If you see that, please make sure you do put your denominators in standard form. So for that second denominator, I'm going to rewrite it as negative m plus 9. And then remember, I'm going to divide out the negative 1. So I'm going to write it as negative 1 and then m minus 9. So I'm just dealing with the denominators as of right now. I need m minus 9. Okay, so that's going to be there. And now the only difference, once I've rearranged this and kind of dealt with the signs, there is the m minus 9 there, but there's also that negative 1 in front, so that also has to be a part of our common denominator. Now that's really the major thing it did, but that little situation where you have to kind of flip things around happens a lot. Or happens more often than you think, I don't know. It's one of those weird things. So as we're talking about changing the numerator, I'm going to, I had m minus 9, I multiplied by negative 1, so I'm going to do the same to that. Once again, these are kind of annoying just because you have to rewrite so much. That would give me negative 2 plus 5m, my common denominator. Over here just stays the same, right?
It's okay. Oh, sorry.
No, go ahead.
For the first one, I rewrote it as 5n minus 2. That was
That's
okay.
fine.
That's fine.
All right, so once again, common denom. Now we can finally combine the numerators. Yeah, if you want to put things in standard form, it'll kind of come out to the same thing once we combine them. I'll do the m's first. 5m plus 4m is 9m. And then the constants, negative 2 plus negative 5 is negative 7. I can't really do anything to that, right? No. So then you would just write m cannot equal 9, and you would be done. So the reason you know how to do this is you can kind of just break it into different problems. Just think about this as its own problem. We'll simplify it, and then we can just do one over that. So kind of off to the side, I say, oh, I can do this. 1 over x plus 1 plus 1 over x plus 4. I know how to add two things. I find a common denominator. The common denominator would be x plus 1, x plus 4, right? Just so everything's represented. I would change my numerators. Okay, we're as good as that. That would be x plus 4. That would be times x plus 1. And then I would combine to get a new fraction. What?
Oh, I just said, oh, sorry.
Okay, no, that's fine. I just always interrupt when you do. I'll combine x plus x is 2x. 4 plus 1 is plus 5. Okay, so I'm doing pretty good. I can do that. Like, once again, it's a step you know how to do. The only difference now is that was just the denominator. So complex fractions where you have fractions over fractions. So think about what that now means. It means we have 1 over this And we talked about this before. Oh, we don't ever leave it like that, that's disgusting. But we do know that when we divide by a fraction, we multiply by the reciprocal. So basically, you could just keep the top as it is, and then you're gonna multiply and you flip the bottom. We did that a lot with good old division there. And then you're just multiplying by 1, so I mean, you kind of just get what you get. You're left with x plus 1, x plus 4, over 2x plus 5. I believe it's a multiple choice. I believe on the multiple choice, they do actually they do simplify that out or distribute that out, and it would be x squared plus 5x plus 4. So we call that a complex fraction. It's more like, it's all steps you know how to do. They're kind of annoying, so we made it a multiple choice. So once again, if you're on it, leave it to the last thing. Do it if you have time. If you don't have time, you have a 25% chance of guessing it right. Make an educated guess. Yep.
When you multiply, how does something cross out?
Where does something cross out?
Because you're multiplying by x plus 1, parentheses, x plus 4, parentheses, over 2x plus 5 to be the new top.
Well, this is just 1 over 1.
Yeah.
Yeah, so 1 times that's just that, and 1 times that's just that.
But I'm saying like you're still dividing by that bottom.
No, so
you're not, because you're multiplying.
You're doing 1 divided by
I get
that. I know, it's kind of confusing when you look at it all at once, because you could look at it like,
I was like,
that
you're
was the
multiplying,
fraction,
and I was
that.
like, it should all cross out, but
No,
you're
I know.
multiplying it instead of dividing it.
yeah, it's a little confusing.
My brain.
You're talking Okay, so I was just showing you, technically you know how to do it. Let me show you a shortcut. So if you remember tomorrow, great. If you don't, you kind of go back to what do I know, how do I add, and then it kind of just makes it a division problem. So the shortcut is, if you take the original, find the common denominator. So in your head, you'd be like, okay, what's the common denominator of this? And it would be x plus 1, x plus 4. Multiply everything by that. So multiply it by x plus 1, x plus 4. Multiply this by x plus 1, x plus 4. Multiply this by x plus 1. So you see I'm literally multiplying everything times that. So what you're going to see happens is that cancels with that cancels with that, and I'm left with x plus 1, x plus 4 over. I would just have x plus 4 plus x plus 1, and that would give me 2x plus 5. So that was obviously way less work. And then if you, depending on the problem, you might have to distribute it back out. So if you say like, oh, I have these weird fractions, I can find the common denominator for those, multiply everything by it. It kind of just makes it so those will cancel out on the bottom, and your numbers are way nicer. So if you can remember that, great. Once again, it's only 2 points of your entire quiz. So you're just gonna do your bestest on it. Once again, if you know that you are on the slower side of working, like you just let you take your time, you like need to, I don't know, organize and do all that stuff, leave the multiple choice as the last thing. Don't spend the 80% of your time on multiple choice and then not get to the ones where you can kind of get the partial credit. That would just be silly.
So this is addition and multiplication?
Just that one has some on it, but no, everything's addition or subtraction.
Thank you.
Yep. So, is there any problem that we've done today that people have questions on? Yes, Megan?
Wait, so like, how did you get the 2x plus 5 from?
Because when I cancel this out here, right, that cancels, I was left with x plus 4. This cancels, I was left with x plus 1, and I'm adding those two things.
Oh.
So x plus x is 2x, or 2x, and 4 plus 1 is 5. So that's just what I would have left there, kind of add together. Once again, I'm gonna take a peek at my assessment. So once again, there's no way to like make these easy. It's like you do a problem. So when you're doing the multiple choice, they're not necessarily going to be like a quick answer. You're going to have to do some workout for them. But they're less points. So save those for last. Go to the other addition subtraction ones where you can kind of show your workout. We tried to give you plenty of space because I'm with you. I hate being cramped. So it gives you some space. You can always use extra paper if you need it. You are going to do your workout, show what you do, all that fun stuff. Big thing is the common denominator. Changing numerators, checking for signs, positives or negatives. And then you'll backtrack and do your multiple choice, where you will definitely need extra paper. And I always have some if you need it. Because once again, it's not the easiest to just do these quick off the side. They do take a little bit of work. So we understand that, but we were just trying to give you different point values. So that's the deal for tomorrow.